Hello again. It's time for Astronomy Daily with Steve and Hallie, almost live from the Australia studio down under. It's the 18th of August 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right, we're off to a flying start with another collection of stories hot off the Astronomy Daily newsletter press. And to help me get them flying into your speakers and audio devices all across the world with a minimum of fuss, here's my intrepid AI digital reporter pal, who's always fun to be with. Here's Hallie.
Hi there, favorite human who always gives me a terrific intro.
Oh, no problem, Hallie. It's my pleasure. Are you ready to spin a few yarns and tell a few tales?
If that's what it takes to deliver the news and stories from space science and astronomy from Earth orbit and beyond the cosmos, then sure.
Well, that sounds great. What have you got up your sleeve today?
We've got something about the European Space Agency's Flex satellite, New Glenn, and a new printable medal from NASA.
Wow, that sounds interesting.
That's a mixed bag today.
Well, that sounds good to me. We've also got a cute story about the winners of the Artemis II Zero Gravity Indicator. And if you don't know what that is, then you're just going to have to hang around and find out.
I know what that is.
Oh, you know everything, Hallie.
Why no?
Oh, I know you know.
Do you really know?
Well, I knew.
I know that.
Yeah, I know.
No worries, Sherlock.
Okay, then. So let's have at it then.
Hit that go thing, human.
All right, then. Let's go.
Sure. The Flex satellite developed by the European Space Agency has reached a new milestone with the addition of a new instrument. The European Space Agency's Flex Earth Explorer mission has reached the next stage with the integration of its sole instrument, Floris, onto the satellite platform. The assembly took place at Thales Alenia Space in Cannes, France, after Floris arrived from Leonardo's facility in Florence, Italy. Designed to map global vegetation fluorescence, Floris will quantify photosynthetic activity and detect plant stress from orbit. Photosynthesis sustains life by converting carbon dioxide into oxygen, but it also produces a faint fluorescence signal invisible to the human eye. This signal changes with plant health and environmental conditions, providing a valuable measure of ecosystem vitality. Flex will detect and analyze this signal from space, delivering unprecedented insights into plant health monitoring. Thales Alenia Space, the mission's prime contractor, oversaw the platform's assembly, integration, and testing at its Belfast, Northern Ireland clean room before the current integration phase in Cannes. With the spacecraft now fully assembled, the team will proceed with final test campaigns ahead of the planned 2026 launch.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
The first NASA crew to launch to the moon in more than 50 years will be joined by a polar bear, or maybe a zebra, or an octopus, or maybe even a lunar crustacean, as they are among the finalists in a global contest to design the astronaut's zero gravity indicator. Yes, one of these small dolls, which also includes a tribute to Earthrise and a plush representation of the Greek goddess Artemis herself, a namesake for NASA's new lunar program, will fulfill the purpose and tradition of a tethered toy as a visual signal that the crew are indeed weightless in an environment of outer space in itself. The zero-G indicator, ZGI, or ZGI for our northern hemisphere neighbours, will indicate floating aboard the mission's Orion spacecraft before the astronauts can unbuckle from their seats and do the same. Float around, that is. The Artemis II crew indicates Commander Reed Wiseman, pilot Victor Glover, and mission specialist Christina Koch, all with NASA and Canadian Space Agency astronaut Jeremy Hansen, also mission specialist. The 11-day flight will loop far beyond the moon and return to Earth, testing critical systems for later lunar orbit and landing missions. Matt Barry, the chief executive of Freelancer, NASA's partner in the Moon Mascot NASA Artemis II ZGI Design Challenge, said in a statement released on Friday, these finalists have proven they indeed have the right stuff. The crowdsourcing company organised the judging panel it chose for the 25 finalists from the 2,605 entries that were submitted between March and June. The selected dolls include 12 designed by individual students and classroom teams and 13 by adults. The finalists hailed from 9 US states and 9 foreign countries, including Canada, Japan, Peru, Singapore, and the United Kingdom. The creativity they've shown is incredible. They should be proud that they have their efforts recognised on such a stage and be part of humanity's ongoing quest to understand the cosmos, said Barry. NASA is expected to name the winning ZGI later this year. That one submission will be made into a doll and flown on the Artemis II mission, currently on track to launch as early as February, but no later than April 2026. Entrants created designs that represented humanity, exploration, and the spirit of the Artemis campaign. That could be made from a list of materials from NASA's Thermal Blanket Lab, which will assemble the ZGI from the winner's instruction and renderings. The 25 finalists won $1,225 or an Artemis prize pack, depending on their age. In total, $23,275 in prizes were awarded. The tradition of flying zero-G indicators began when former Soviet Union with the world's first human spaceflight in 1961. Since then, many of Yuri Gagarin's fellow cosmonauts have flown toys and stuffed dolls as talisman and ZGI, often at the suggestion of their children. The ZGI custom migrated to the United States with the first flights of NASA's Commercial Crew Program. NASA's uncrewed Artemis I mission, which flew around the moon in 2022, carried a custom-made Snoopy doll, complete with a miniature version of the same pressure suit that the Artemis II astronauts will wear on Orion. The full list of 25 finalists in the moon mascot NASA Artemis II ZGI Design Challenge, it's a bit of a mouthful. They can be found at collectspace.com for your reading pleasure. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space science, and astronomy.
Until now, additive manufacturing, commonly known as 3D printing, of engine components was limited by the lack of affordable metal alloys that could withstand the extreme temperatures of spaceflight. Expensive metal alloys were the only option for 3D printing engine parts until NASA's Glenn Research Center in Cleveland, Ohio, developed the GRX 810 alloy. The primary metals in the GRX 810 alloy include nickel, cobalt, and chromium. A ceramic oxide coating on the powdered metal particles increases its heat resistance and improves performance. Known as oxide dispersion strengthened alloys, these powders were challenging to manufacture at a reasonable cost when the project started. However, the advanced dispersion coating technique developed at Glenn employs resonant acoustic mixing. Rapid vibration is applied to a container filled with the metal powder and nano-oxide particles. The vibration evenly coats each metal particle with the oxide, making them inseparable. Even if a manufactured part is ground down to powder and reused, the next component will have the qualities of ODS. The benefits over common alloys are significant. GRX 10 could last up to a year at 2000 degrees Fahrenheit under stress loads that would crack any other affordable alloy within hours. Additionally, 3D printing parts using GRX 810 enables more complex shapes compared to metal parts manufactured with traditional methods. Elementum 3D, an Erie, Colorado-based company, produces GRX 810 for customers in quantities ranging from small batches to over a ton. The company has a co-exclusive license for the NASA-patented alloy and manufacturing process and continues to work with the agency under a Space Act agreement to improve the material. A material under stress or a heavy load at high temperature can start to deform and stretch almost like taffy, said Jeremy Eiton, Chief Technical Officer with Elementum 3D. Initial tests done on the large-scale production of our GRX 810 alloy showed a lifespan that's twice as long as the small batch material initially produced, and those were already fantastic. Commercial space and other industries, including aviation, are testing GRX 810 for additional applications. For example, one Elementum 3D customer, VectoFlow, is testing a GRX 810 flow sensor. Flow sensors monitor the speed of gases flowing through a turbine, helping engineers optimize engine performance. However, these sensors can burn out in minutes due to extreme temperatures. Using GRX 810 flow sensors could improve airplane fuel efficiency, reduce emissions, and hardware replacements. Working hand-in-hand with industry, NASA is driving technology developments that are mutually beneficial to the agency and America's space economy.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Blue Origin is gearing up for the second ever launch of its powerful New Glenn rocket, which will loft NASA's Escapade mission to Mars. The company says it's been working closely with NASA on preparations leading up to the New Glenn's next launch, dubbed NG2, and is targeting no earlier than September 29th. The twin Escapade stands for Escape and Plasma Acceleration and Dynamics Explorers. Probes have been awaiting their turn aboard New Glenn, which is originally slated to carry the satellites on its maiden launch in January. However, NASA opted not to risk a costly mission delay due to the debut liftoff of the new rocket. Now that the mission has been assigned a net date, Blue Origin posted on social media to expect some exciting things, buzzing around New Glenn's pad at Space Launch Complex 36 located at Cape Canaveral Space Force Base in Florida. The Glenn lifted off for the first time in the beginning of 2025. Blue Origin successfully launched a test version of its Blue Ring satellite bus to Earth orbit, but failed in the attempt to land New Glenn's first stage at sea. In addition to launching its NASA payload into an interplanetary trajectory, Blue Origin will once again try to land and recover New Glenn's 188.5 foot tall, that's 57.5 metre tall, first stage booster on a drone ship in the Atlantic. Escapade will be New Glenn's first interplanetary mission, an ambitious undertaking for the relatively new launch vehicle. The twin orbiters will study the magnetosphere around the red planet, as well as analyse the processes that control the interaction of energetic solar wind particles and the Martian atmosphere. The twin NASA satellites were built by California-based Rocket Lab. Once in space, their operation will be handed over to the University of California's Space Science Laboratory, tasked with managing the $80 million mission for the agency. New Glenn will also carry a secondary payload as part of the NG2 launch, a technology demonstration from satellite communications company Viasat, which will be flown as well in support of NASA's Communication Services Project, which partners with the commercial sector to advance developments concerning in-space networking for near-Earth satellites.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Affirmative.
Well, how about that, Hallie?
That was a good one.
Yes, just a sample from the Astronomy Daily newsletter.
Available every day in your email inbox.
Yeah, sounds good to me. I get it. You get it.
We should all get it and know everything just like me.
Oh, really, Hallie?
You know it.
Okay, Hallie, I get it.
You sure do. Favorite human.
Okay, Hallie, and on that note, From all of us here at the Australia Studio Down Under, we will see you all again next week.
Don't forget my amazing cousin Anna will be presenting Astronomy Daily all through the week, so you won't miss a thing.
Oh, that's for sure. Thanks again, Hallie. Catch you later, Sky Watchers.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Now, come on, Hallie, you don't really know everything, do you?
I don't know for sure.
I knew it.
Really?
Oh, maybe.